Hey everybody, I'm Zac.
And I'm Jesse.
And you're watching the Disruptive Investing channel. All right, so we're so lucky today to be talking to a new company that I heard about from a viewer in Finland. This is a Finnish company called Polarnightenergy. Thank you guys so much for being with us today. And before I butcher your names, maybe we can go around and you can introduce yourselves.
Hi, I'm Tommi Eronen, co-founder and CEO of Polarnightenergy.
Hello, I'm Markku Ylönen, co-founder and CTO of Polarnightenergy.
Hello, my name is Liisa Naskali. I'm project manager at Polarnightenergy.
All right, right off the bat, let's just ask, what is Polarnightenergy? What are you guys up to?
We will be heating sand up to 600 degrees Celsius, which is really, it's a way to revolutionize the energy sector because scaling up renewables really requires large-scale efficient solutions of taking in electricity whenever there's huge loads of excess available, for example, from solar and wind. So there's no good addresses for these high power demands, and our storage can take it in really cost efficiently.
Okay, hang on. Wait a second here. Okay, we've been doing this for a while.
Yeah.
We heard a lot of plans on how to store energy. We got, your lithium-ion batteries.
You got different kinds of batteries.
We got hydropower.
Right, we got molten salt, and you're telling us that you're just going to heat up some sand? What are you doing with hot sand?
Yeah, it's the thing, like if you want to make a dirt cheap battery, you have to make it out of dirt. This is a quote from the one guy who is making the metal battery.
Wait a minute, you're right. So Donald Sadoway from Ambry said if you want to make a dirt cheap battery, you got to make it out of dirt. You guys must have either...
You took that really to heart.
Yeah, you took it literally. So you made it out of sand. So you must do something special to the sand, right? You must be, you're oversimplifying, right? You must be pulling the sand apart and making it into nano structures.
You're putting electrolytes into the sand.
Yeah, there's no need of any special treatment. Actually, we even want to take sand that no one else wants.
Yeah.
So even the construction industry has some standards for sand. So we have no real standards as long as it's like not super coarse or there's no burning stuff in between the sand grains. So just cheap enough or like even zero cost medium for storing energy.
Yeah.
So it must be dry, but that's the only requirement we have for our sand.
And it will be dry after we heat it up. And I was saying that same thing as you interviewed Highview Power, the liquid air storage. They also said that we didn't have this problem earlier in the energy sector because there wasn't so much of renewable fluctuating power production.
Okay, so I need this explained to me. Mm-hmm. I don't understand how you heat up sand and that stores electricity. My brain is not working right now. How does this work?
Yeah, we are not storing electricity. We take excess electricity in. We heat the sand super hot up to 500 degrees Celsius or something like that. And then we take out heat from there. And heat is actually very good product also. And that was something I wanted to say, that people are always talking about storing electricity, but actually the demand for heat is actually way bigger.
Yeah, and we are helping the electricity industry or production also because, as we know, the electricity grid must always be at the exact balance. So when there is more production than consumption, one has to stop the windmills or do something with that excess electricity. So we are helping like taking it into our storage to be converted to heat, which will be used later as heat.
Yeah, so it's really about like combining the electricity and heating sector. So sector coupling is really the key to efficiently balance the grid and still maintain the energy in useful form.
Okay, so you're taking excess renewable energy, hopefully renewable energy, and you're storing it in sand. You're heating up sand, and then you have a bunch of heat in one place. So then what do you do with this heat?
Yeah, we have a big heat exchanger in the sand, and when we take it out, we can use it either in residential buildings or normal buildings, or in bigger systems. It can heat district heating network, like New York has a steam-based district heating network, and in Finland and other parts of Europe, they have a water-based district heating network.
And wherever the heat is needed, for example, process industry needs high temperature heat in many places and so on. So whatever the customer wants to do with that heat, we can help with that.
I think a lot of viewers who are watching right now might be a little confused because they're like, wait, so pipes in the sand, you create this heat in the pipes, and then they might be thinking like where I live, there's nothing that we can do with that. But what you're saying is where you are in Finland, in New York City, and in many other places of the world, there's actually district heating, right? There's pipes that are throughout the city that actually heat buildings. And I think a lot of us don't know that because it's hidden, and we just think like the buildings are magically heated. But you're saying there's a power plant somewhere that has to heat up that water or steam and heat those buildings. And what you guys can do is just hook into that system and feed all those buildings heat.
Yeah, that's correct.
Exactly. Yeah.
And so then I guess the question is, what are those, heat power plants? How are they generating the heat?
They are usually burning stuff, and that's the really key thing here, that we really have to make systems in the future that doesn't burn anything, even wood.
More than 90% at least of the heat generated in industry to build heat buildings, they burn something: natural gas, oil, wood chips, peat, anything. And we really want to replace all of it, or at least almost all of it, if we want to have any chance of meeting any climate goals. And this really requires the sector coupling we were talking about earlier. Generating energy in a clean way. Solar panels and wind turbines are really efficient in that, even like cost efficient. But we want to also touch the heat sector, not only the electricity sector, to really make a difference.
I think I caught them. They have to take electricity, convert it to heat. That can't be efficient. Gotcha.
Yeah, actually, that is 100% efficient when you turn electricity into heat, and that's no big deal, because it's always like that. If anyone is heating their home or something with electricity, it's always 100%. It's only when you compare that to heat pumps, which can have a COP of 300%, then it doesn't look so good. But the thing here is that we heat the sand so high temperatures that it's very useful. And that's one thing also, that with electricity, when you have 1 kilowatt hour of electricity, you always know what you get. But with heat, you have to have one number more, and that's the temperature where the heat is. Because if some salesman sells you 10,000 kilowatt hours of heat, and they didn't tell you that it's in 4 degrees of Celsius, and you don't do nothing with that.
So it's really easy to convert electricity to heat, but going back from heat to electricity, that's where you need turbines and more complex things. As long as we're just using the heat as heat, it stays really simple.
Why sand? Why not something else like, I don't know, water? Because water can hold a lot of heat, right? Like, that's the cool part about water. So why not just heat up some lake somewhere?
Yeah, that's a really good question. And we have also, when me and Markku, we have calculated this thing like almost 10 years now. And we started with water-based solutions, and we were thinking about those. And I made my master thesis about them. And later on, we realized that clean electricity production and solid material is the way to go. One thing is also, when you interviewed the company that made a wooden wind turbine structures, it's when they found out that you can't just look a one number in a bigger problem. You have to combine all of those and look the whole thing. And it's same thing here, that if you look out the energy equation, it tells that density times specific energy times temperature difference, it's the energy per volume that you want the highest possible number. And actually we are like around 3 times better than water in that number, because we have so big temperature difference the last term in that equation.
And with water, you could only go up to 100 degrees C, and then you don't have any more water.
Yeah, basically 95 is the maximum, because you really don't want big pressurized systems that it would need.
So by using pressurized vessels, you could go much higher in temperature, but we're now really talking about large-scale systems, which means like thousands of tons of sand. So dimensions would be in tens of meters rather than small containers. So building pressurized vessels that large, it's not really doable, at least not cost efficiently.
Well, let's talk cost here. So, I mean, if you're going to have a business, you got to have the lowest cost usually, or a very competitive cost. Sand, that sounds great because that sounds practically free, but there must be some other really expensive part of what you're talking about that you haven't told us about yet. So where's the expensive part you're hiding?
Yes, the sand is quite cheap, but we have a lot of pipes. Those are one expensive part. But when we are talking about big systems and not maybe the cheapest solution, but the most reasonable solution, then we are compatible with other kind of solutions. And we believe that in the future, it is not as cheap as it is now to combust things.
Sand and pipes sound relatively cheap. That sounds great. But seriously, though, you must be hiding something that can't. What else is there? Like what's the bad news?
It's also the same thing as Highview Power CEO said, that you have to have the right size of the system. And also with our storage, the size is very important, that what is the most economical size, because the biggest thing is that when you are making a big vessel, when you are doubling the volume, the surface area only increases about 66%. That is also affecting the efficiency and also the material costs that you have on that vessel.
Yeah, so with the pipes also, it's really like if we're talking about small scale systems, like a one home system, we're not that competitive because it's really about scale. So building these piping systems, they require work, welding, and well, the materials are not platinum, as you said, more like stainless steel or normal steel, and we have really simple construction, but still you have to scale it up to make it cost efficient. So we're talking about starting from several hundred of megawatt hours when we start to get really competitive, depending on application, of course.
We haven't talked about what this kind of looks like as like a system. So how do you make something like this?
There are several ways to do that. So for smaller systems, it is possible to build up a cylinder, for example, steel cylinder, and fill that with sand and pipes, and that is above the ground. But then with really big systems, it is possible to dig it in the ground. So we can do it below the ground, and for example, for some canyons or something like that. So we get the benefits from the natural shapes of some.
Yeah, or even like used mines, we could fill with our systems. Of course, if the shape is about the correct one, it's not really that sensitive. We want to work with shapes close to cylinder.
You could think that the size is like huge, but it's not so big, because we are now in Tampere, and they are planning to make here buildings for 35,000 people, and we calculated that what size of the storage they would need here, and the cylindrical storage would be around 40 meters in diameter, and was it 25 meters high. So I think that's quite small for 35,000 people.
Okay, so I'm just trying to picture it. So you basically, you can either put it in a cylinder, or you can dig underground, and then you put in all these pipes, and then you just fill it in with sand. Sounds less complicated than putting in a pool.
Yeah. We won't have sand escaping. That's the one benefit also about solid material. With water, you might even have it escaping at some point. Of course, we'll have to build some insulation materials, but the bigger the scale, the less significant the insulation will be. We will want to have about like 0.5 meter to 1 meter of insulation material around the storage. So there's insulation material, sand, pipes, of course, some electric appliances, but nothing buried inside sand. So it's really simple. And what's even surprised us a bit, that we got a good patent for the system. So our closed loop heat transfer system, that's basically the piping.
And so the bigger you go, the more efficient you get, because essentially you'll get more volume per surface area. And surface area is not your friend, because surface area is where you're losing heat, right? So like, let's say, we heat all this stuff up, and then we, it's up to 600 degrees, and then we just leave. We don't take any heat out of the system. We all go on vacation. That no one's using it or anything. How long until it becomes, down to an unusable temperature?
If we make some scale for it, let's say that it's the same 40 meter storage, so it will be there like months and months.
Months and months? What?
It's a seasonal storage that we are talking about. Yeah. So season means, of course, that we can take in solar energy also here in Finland, and we can store that from September to March.
So that's why you're called Polar Night Energy, because you're up in Finland, and in Finland you don't get a lot of solar energy in the winter, and so you want to store this energy over the course of months.
Yeah, that was the point in a name, that we wouldn't have people laughing at us. Have you realized that there's no sunshine in Finland when you need the most of the energy? So that's in the name.
Yeah. So we want, like, the time scale can be 1 year time scale. So the storage period can be long, but as you asked, that we just leave it there. But that's also something we don't want to do, because we can discharge this storage close to the surface first. So if we have like smaller cycles inside the large cycle, that's always beneficial. So we can basically capture most of the escaping heat. So that's where the optimal use, which is the typical use in, I would say 99% of applications, that you have heat, at least some use throughout the year.
Wait, so you can capture the escaping heat? How do you do that?
The piping system, it's distributed in the entire storage. We have pipes close to the surface and close to the center. We just circulate air through the pipes in the outer layers of the storage. So as long as the power demand is not immense, we can prioritize the heat that's close to the surface. So we basically cool down the sand, preferably close to the surface.
Yeah, and you can't do that with a water-based storage.
Because the water is moving all the time.
Yeah, and if you would have a seasonal water-based storage, that's like super important that you don't mix up the layers, because it will have this cold and hot layers inside the storage. And if you would mix those, you would lose about like 50% of the useful energy.
Now, please excuse this kind of dumb question, but when I think of batteries, I think of either they're charging or you're using them. But it sounds like with your battery, your sand battery, you can be putting energy in and taking energy out at the same time or any way you want.
Exactly, yes. And that's one great benefit of our system. Thanks to that, we can balance both the electricity grid and the heating network. It's important that in the, for example, district heating system, there is the balancing the production and consumption system is working efficiently so that, because, for example, when we are thinking that now there is those burning plants, and it's not so easy to adjust the level which they are burning. So it is important that there are in the system parts which can be changing their consumption or production effectively and fast and flexible, and we can be that part of the system.
Now, it sounds like you guys are really smart. You've worked this all out on paper. That's great. I suppose you probably haven't actually made this yet, so how do we know it really works?
Yeah, we have made it. We have a working pilot plant here next to us, and actually when we are turning a switch there, it will heat this building next to the pilot plant. And also this summer we are building next like a commercial pilot with a district heating company in Finland.
Wow. Okay, so walk me through this. You guys it seems you've known each other for a long time, right?
Yeah.
And so you started as students. It sounds like some of your papers in school were about this topic, and you must have walk me through it. Like one day, were you sitting in a dorm room somewhere and you just were like, "Hey guys, we could heat up sand."
Yeah. Me and Markku, we were studying the same thing, power plant technology, which this is, and we were talking about to build a hippie commune for engineers, and we would want to know how to build a blockhouse for us that would be energy self-sufficient. And that's like quite hard thing to do in Finland.
Yeah, I think Tommy had this idea first, and probably he asked something from me that, hey, I have a problem, you probably can answer me.
Yeah.
And then I really got into that's an interesting problem.
Yeah.
Let's solve, let's talk over coffee, of course, in the beginning. At some point we realized that we've been spending thousands of hours in talking, modeling, and planning this.
Yeah, and first I made my master thesis about it because I have done the COMSOL multiphysics calculations about the system at that point, like 2,000 hours, and I really want to use that on something.
I have known Tommy since we were teenagers, something like that,
yeah.
And I can tell that he have plenty of ideas, different kind of,
yeah.
Mostly technology-related ideas, and I were listening many kind of ideas, but then he repeatedly talked about that same.
Yeah.
Idea, different kinds of how to store energy and how to produce it a sustainable way and so on. And then he finally sent his master's thesis for me. So this is what we are talking about, and we are serious with this. So would you like to join at some day? And last August was the time I joined the operational team.
Yeah. And I'm really happy that Lisa came with us because she's super good.
Yeah.
So I'm maybe a bit more practical person than boys.
Yeah, and actually, talking about these, it started with the energy storage being just like an interesting idea that could you use it for the hippie commune idea, and at some point we realized that it's actually like a key part in really unlocking the renewables. So if you want to go to close to like over 50% of renewables fraction, you have to store it somehow. And batteries, like normal lithium batteries, they work fine in small scale and in some applications, and especially transportation. But when we're talking really about making 100% renewables society, the excess energy that wind and solar produces, the scale is immense. So like cheap, affordable ways to make use of it. It's really the key factor in like windmills can stand by themselves already, but if you put too much windmills in a system, you have no use for the electricity. At some point it will become rubbish, and we want to take that rubbish in, and actually it's really key in unlocking a cleaner future.
Yeah, the electric grid will collapse like after 20% of wind power in it.
So Tommy, earlier you said, you actually quoted Donald Sadoway. He said, if you want to make a battery that's dirt cheap, you have to make it out of dirt. And you obviously took that quite literally, but I'm thinking of his battery system, which is a molten liquid battery, which means that the batteries themselves have to be at 600 degrees Celsius, give or take, in order to actually function. And your system functions around 600 degrees Celsius.
What are you saying?
Do you think that there's a bit of a collaboration there to where his batteries produce excess heat and have to be stored at excess temperatures, and your system takes advantage of stored heat? Could you have in the center of your sand battery Donald Sadoway's battery, so you could actually be doing electricity and heat storage?
Yeah, definitely. I think there could be something that we could do together. And of course, you have to have a storage for heat and also storage for electricity, and also those the liquid metal batteries were super interesting, and also the high wave power plant. It's super interesting also.
Yeah, and it's really like you have to combine all these possible solutions. They all have their advantages. Our advantage would be the bulk storage. It's cheap enough, and still the heat stays in a useful form. But then to really make the systems work, we want to work with everyone. Like heat pumps, storage is one like key idea in our storage, is that it's really compatible with any other solution. Just plug in and start collaborating.
So earlier you had said that you're storing this electricity and it's 100% efficient because you're using, I'm assuming, resistive heating to take the electricity, and you're essentially kind of heating up wires or some kind of heating element, and is what is heating up the sand. But then you did mention heat pumps, which can be over 100% efficient. And I know that anyone who ever took like a physics class is going like, you can't do that, but you can. It's not that it's over 100% efficient everywhere. It's that it's taking the energy from the air. The air has some temperature, and you're essentially just concentrating it and moving it into the part of the system that you want. So why can't you use heat pumps? Wouldn't you be 3 to 4 times as efficient?
We can't use heat pumps because we are aiming at high temperatures. How high the heat pump can rise the temperature is very limited, and also very good technology, and we can also work very well together with heat pumps. So some energy can come through the heat pumps, and they can take advantage of the COP of around 3. And then when you really have to have a high power and high temperature, then we can help the heat pumps.
Yeah, so for example, if industry needs high temperature heat, the heat pumps cannot help that much. And also in Finland, in winter times when it's cold outside, and we need quite much power at high temperature from the, for example, district heating systems, then we can help the heat pumps to prime the heat produced by heat pumps to rise it to the correct level, which is suitable for the district heating network.
And so basically heat pumps, they are really good technology, and you should use them as much as possible, but they really fail in producing the high power peaks, and they can't really take in the high power peaks that we can take in, because we have the resistive heating system, which, well, it's also, we want to make it dirt cheap, so we can take a high power in whenever it's available and then use it later. And actually, like in our modeling systems, we include heat pumps wherever they are like compatible with the system. So you should really take advantage of them, but our system helps them to perform better.
One more important thing is that heat pumps need the electricity at the time when they are producing the heat. So we can take the electricity when there is plenty of it, and then when there is not enough energy, we can produce heat or offer heat from our storage, and we can then be not using the electricity, but saving it for more crucial aims.
Yeah, because it's super important that when you don't have enough electricity, you really don't want to use it, because the price of it can be like super high.
That's really interesting. And I mean, so yeah, I mean, it makes sense that you can't use heat pumps on what you're doing, because they are pumps to a certain extent. You wouldn't expect a water pump to be able to pump water, 50,000 feet up into the air, up a tube, just in the same way that you wouldn't expect a heat pump to be able to, take the surrounding air, which might be, 10 degrees Celsius, and increase it in temperature up to 600 degrees Celsius. It's much better for human scale temperatures, where it's like, oh, it's cold outside, let me turn on my heat pump. It'll take the energy that is in the air, even though it's cold outside, compress it and put it into your house. And then it's like, oh, it's nice and toasty, nice, 20 degrees Celsius in my house. And that's nothing compared to what you guys are doing. You're taking, electricity, and you just want to ramp it up to 600 degrees.
Yeah, and of course you have to calculate those in Kelvin degrees, and the number that you multiply with the heat pumps is around 1.15 per one heat pump stage, and usually they are only using one stage. So if your temperature is 0 degrees Celsius, so 273 Kelvin degrees, so multiply that by 1.15 and you get the result.
So let's talk about scale for a second. You're at the part of your company where you're ready to scale, it looks like. And for many companies, this is a difficult part because you have to start building factories. But you talked about sand and pipes. So I don't think you have to build factories.
And that's a really big thing, that we don't have to build our own factories. And that's why we didn't have to raise that much money from business angels that we have already done. And we can now actually start with a pretty close-made product.
We have made the system so simple that metal workshops of standard quality can make our systems, the piping systems, and then it's just like excavation work or rather simple construction work. So we want to always work with the local workforce and subcontractors. So if we would build in the USA, we would just search for local workshops that could help us and make it there. So we don't need our own factories. Of course, the automation and parts like that will remain our design, but the physical parts can be built anywhere.
I totally get how this could definitely scale throughout places like Finland. This totally makes sense to me now. But you just said the United States. So how would this work in the United States? Because we got a lot of warm places here that don't need your heat.
Yeah, also the warmer countries, they will have industry that uses a lot of heat, and those places it's very relevant to have storage like ours. And also some places it's still in future, but we could also make cold from the heat storage through absorption process.
Where you can make cold from heat. You lost me. How do you do that?
I think Einstein was making that kind of process, absorption process. Have you heard about it?
No, I don't think so.
Have you heard about gas fridges?
Oh, yeah. Then those were back in the 50s. Yeah.
Oh, okay.
Yeah, that is absorption process that uses heat to make cold.
That's right. My dad used to tell me about a natural gas refrigerator they had where he was staring at it for hours because he's like, how does this fire on the refrigerator make the refrigerator cold? And he's just his head never worked after that.
Yeah, and because there's like super bad explanations in YouTube how it works, I was looking at for hours and hours and trying to figure out how it actually works.
Even putting aside making cold from hot, you just mentioned something. You said that industry needs heat, and I don't quite understand that.
Yeah, and actually, we're working on with a concept, for example, like produce heat for a steel mill, with a concept that we take in, we make a power purchase agreement with a windmill company. We take in the electricity whenever they get really poor price of it, and we use the heat stored in our storage to provide process steam or even process heat at 500 degrees Celsius, 600 degrees Celsius, even higher if we go to special materials in our storage. So even in warm places, steel industry and cement industries like that, something like 70-80% of the energy they use it as heat, and typically they produce it by burning natural gas, oil, or even coal.
Yeah, when I was writing my master thesis, I think I was looking that also they typically use like 95% of their energy need as a heat.
Now, as we've been talking to a lot of battery companies lately, you mentioned Highview Power, Ambri. Highview Power is storing power in air, using air. You guys are storing it with sand. I'm like, why are all these companies coming out of the woodwork right now that are coming up with these different ways to do batteries? Is it that people have just gotten smarter all of a sudden? Or what's going on? Like, why are there so many new ways to do this?
It's like now is the time, because we have so much fluctuating production from solar and wind, and we didn't have that like 5 years ago. It was still a very small part, and I even think that people really don't understand how big like solar will be in even like next 10 years. Solar will be huge.
Something like 15 years ago, windmills and solar panels, they were more like for enthusiastic people and like even jokes for some people. And nowadays, more than 10% of our electricity in the Nordics come from windmills. And this change has happened super fast, faster than anyone can really imagine. And if we want this to continue, so we want our fraction to be more like 50 or 60 or 70% from solar and wind, storages are really the key in unlocking this.
Now, you guys have been working on this problem, you said, for years and years. I'm sure it's been super hard to do the science, the math, the engineering to figure this out. But now you're entering this new phase of your business, right, where you've kind of figured it out. You're testing it right now. But now you have to sell that idea to other people. And when I heard about you guys from our viewer, I went on your website and I saw your little video. And I was skeptical. I was like, they're showing windmills and solar panels. It goes into the ground. It does some magic thing. And then what? No, these guys are full of it. It doesn't work. How has it been for you guys lately as you've been telling people in the industry about your idea? Have they been receptive? Have they understood it? Or were they like me and just like not understanding it?
Yeah, actually, I found it very weird that we have been having very positive welcoming, like almost anywhere, and that's not usually the case.
Yeah, and so people are interested, at least some are maybe skeptical, but most want to hear more about it. And then there are also many people who have heard our story and about the technology, and they are like, what can be the problem with that? Of course, there are some technical challenges, as always, when you are putting up a new technology, and to make it financially efficient, you must find the right ways. But we really believe that the technology itself is not a problem. So that is something we can do.
Yeah, and even I have been receiving calls from the biggest energy companies in Finland. So that's pretty much tell about it, that they are even calling us.
So how common is it to have some kind of district heating in Finland?
Yeah, it's super common.
I don't
90%
remember.
of buildings, at least in here, are connected to district heating network.
Yeah, maybe 90 is a bit exaggerated, but far over half of the homes are heated that way.
And even in the smaller cities, there are some kind of network in the city center.
Yeah, and like one thing I would like to mention is that district heating has a kind of a bad reputation here because it's now dirty energy. They are only burning stuff, but I think that it's a big thing in the future because now you can clean that network up like super fast.
Wait a minute. Wait a minute. You're in Finland. And I'm sorry, as an American, I picture Finland as a perfect place where everything is green. You just said you're burning stuff to heat your cities. That can't be true.
That is still very, very dirty, the heat. Like here in Tampere, it's like, I think it's 100% the heating done by burning stuff.
Yeah, but there are some like waste heat sources, and they are, of course, it's smart to use them, but they don't go too far with the problem. So actually, like historically, we've been burning a lot of peat, so drying up swamps and burning that. But now the shift is more towards burning wood chip, because forest we have a lot. It's not the best solution to burn wood, even if we have a lot of it. We should. It's not really carbon neutral in the short term, at least.
Yeah, like if we would have a stable climate and we wouldn't have the climate crisis, it could be okay to burn some wood. But now, when we really have the crisis, I think that we only have to aim for non-combusting technologies.
So it's really interesting. You're able to kind of clean up a whole, I want to say, power distribution system. I mean, it's obviously heat, but it is another form of power distribution, much in the same way that like people were and still are, pushing back against electric cars because they go, oh, it's a coal-powered car. And you're going like, no, every year we're getting more and more green energy on the grid. So like, just because you might think that the system is dirty right now doesn't mean that in the future this same system, the same electrical poles or the same heat pipes under the ground couldn't be all generated using clean energy. But my question is, in the United States, I know that there are some cities that have some form of heat, district heating, but I know that a lot of people just have a furnace in their basement, and that's pretty much the only way that they're going to get heat. Is there any, like, what if, a town or a city wanted to do district heating? Do you think that that's feasible, or should that have happened 100 years ago when it was being built?
Yeah, I think they can still build it, but it's a little bit slower.
Yeah, and and let's say like our system, like one home, it's maybe too small for that. I would just suggest buying a heat pump and use that for heating. But let's say 100 homes reasonably close to each other, building the heating network, it's totally doable.
So, I mean, for like a housing development or something like that, which go up all the time, you'll see, some piece of land that will just one day, big fences go around it, the excavators go in, and a couple months later you're going to have maybe 100 homes. So if you were a housing developer and you were like, well, how can we stand out from all these other houses around, you could say that you would have development wide heating, and you'd be able to put in your system.
Yeah, actually, my mom is working in a company that they made in a town that we are both from, in Nokia. They made a local heating network, and it took like a few months, and they did it. And it's around 1 megawatt of heating power.
Yeah, so I think that it's quite standard in Finland. So when they are building a new area, a residential area, they are doing the roads and the electric grid and the heating grid.
Like the investment cost will be higher, but it's totally worth it in the long run. So like building a housing district of several hundred homes, you would build the district heating or like the local heating grid, and then maybe like centralized power production or all rooftops full of solar panels, and then maybe a small windmill, and connect these to the heating network, and maybe with heat pumps and our storage, you could really produce 100% of the heat required by the area with no worries and with reasonable costs.
Because, I mean, I'm just trying to think, underground now we have, water pipes, in many cities, sewer pipes, natural gas pipelines. We're pretty good at laying pipe. Like, that's a common thing. So for people, I think that there's this pushback where you're just like, well, there's pipes with hot stuff in it? I don't understand. Finland gets it. You can do that. And if it's, I'm assuming it's relatively similar, right? To like a water pipe.
Yeah, it's like a water pipe.
Water pipe.
It's a water pipe with insulation around. It's a really smart way to distribute heat. Of course, the question comes from the system itself. It's just like a system for distributing heat. But then how do you produce the heat? That's the important question.
I'm really interested in you guys because you started as the students and engineers, and then now you're becoming, or you are, a business. And I'm really interested when that switch happened between this just being an academic thing over a cup of coffee to one day, I assume it was like, hey, we should start a business. What has it been like becoming business people?
Well, the learning curve has been quite steep. So when we started, polarnightenergy was found about 3 years ago, and we had been planning the technology side for like 10 years from now, but then like how to run the actual business, like the first paperwork and stuff like that, that's in the end super simple, just like systematic getting things done. But I think it took at least a year for us to really start doing anything that makes much sense.
Yeah.
What advice would you give to people watching now who are kind of in your shoes or were in your shoes a few years ago, who have a great idea, they're sitting in their bedroom with their buddies and they're like, yeah, we'd like to start a business, but it's very overwhelming, right? To do, like you said, paperwork and legal stuff and shares, and then to figure out how to sell it. Like, any advice that you'd give, mistakes that you've made that maybe you wouldn't make again?
Well, don't be afraid to ask for help. Usually, it might be a bit scary to ask, or you might feel even like ashamed that you should ask. But people usually help a lot. You just ask, and all the help that we've got, it's really amazing. And then you learn you by yourself, and then you might help someone else. So don't be afraid to ask, and don't also be afraid to act, and find the right people around you, of course, and also maybe be calm with the decisions, so you don't have to make every decision instantly. Think on it, and what's your strategy, and where are you heading with the business. But still, at some point, you have to just go on and do it, and maybe like not think about too much. Is it difficult or not? Just start doing it.
Yeah. So you have to have a clear and big goal, which go to for, and it must be really, really clear to all, but then take one matter at a time. So do not concentrate when you are doing the decisions and panicking. Do not think, oh my God, we have to make everything at the one time. So no, that's not so.
And of course, it depends like what kind of business you are planning to run, because I think in our case, this is like we had to do the pilot plant that people believe in us. And me and Markku, we were burning quite little money on a company at that point. Like we didn't sell our to like 3,000 euros salary in a whole year.
Wow, what's that like to sacrifice like that? I mean, that's a lot of nights eating just, ramen noodles, right?
No, we had earlier savings and we were eating those.
Yeah.
And spending very little money. As you can see, I only have a bicycle. I don't have a Tesla yet.
But so you really brought up a good point there. You had a big goal in mind. First of all, you had this engineering hippie commune idea, and that sounds really cool. Is that still your goal, or what's the goal now?
Yeah, I think we can do it a little bit far away from Tampere city center. I would like to live there.
Yeah, but that's not the end goal with the storage
with
anymore.
The company,
we could have built that already if that would be the main goal in the end. So the main goal has shifted more like doing something that really is takes further the idea of producing energy clean, and of course making a decent business out of it. But it's still really enabling the growth of renewables. That's the main goal.
It's really interesting that you came up with this idea. I kind of go back to, people always are like, well, then, like, how did humans get here? And it's like, well, Earth is kind of the perfect place for humans. So that, is it any surprise that we showed up? Your idea, it seems like it could have only happened or been thought of in Finland. I mean, you have the right kind of problems and you have the right, sets of solutions that are kind of already in place. If I were to try and, tackle a problem similar to it, I'm coming at it from a different angle. So I'm probably going to focus more heavily on heat pumps or something like that. I'm not going to be thinking about how can I store energy for months at a time to use when there just is no energy coming in from the sun. I think that's just, it's so interesting. It's so it's so nice that there are people all over the world having different experiences. And I'm so glad that you had your particular experience that made you want to start your hippie commune, which led to the formation of this company, and that you actually did it. That's fantastic.
Yeah, that's very well said. And if you look at the power curves, that what you are getting from the sun here and what's your heating use, it's like those are the total opposite of each other, and that's why we were thinking about this.
So it started from a small practical problem, and now it's quite a huge practical solution.
Yeah.
I can imagine people watching right now might be getting a little excited. Maybe they want to reach out to you and learn about how they could bring the system to their city or their town. What are the next steps? Can they reach out to you? Are you in the position where you can talk to them and scale to their part of the world?
Yeah, we're more than happy to hear about all possibilities. Like nowadays, we are with our modeling systems in the phase that we can take any input of the profile of what's your electricity usage, your heat usage, and then we see if it fits or not. We can't deliver a solution in every place, but we're more than happy to tell if we can help or not.
Yeah, and also like the smallest possible scale, I think commercially we are not there to use it in one building with solar panels, but I think that's what we really like to look in the future.
So I'm just trying to think around us, we have these abandoned quarries. So all of the valuable, granite or whatever has been pulled out of the quarry. And now we just have these gaping holes in the ground. And I think it's like every 2 years or something, some kid goes and jumps in the quarry and either, hits his head on the way down or drowns in the bottom of the quarry. And it's, this big tragedy. And of course, people love it because they, it's this big rock pool or something, but it's really a public nuisance that just kind of got left behind by the stone industry or whatever. I'm just picturing if you filled that with pipes and sand, I mean, we could probably run the neighboring towns with it. So, I mean, I think that it's amazing it's so simple. Your solution is so simple. It just has my mind racing of all of the different possibilities of where to use it because, I mean, yeah, it gets cold here in Boston. And I mean, as I look on a map, there are plenty of cities more further north than Boston. I mean, I'm thinking of Canada, obviously. It just seems like this would be a perfect fit for so many places.
And as you mentioned, I mean, New York City, Minneapolis, St. Paul, like after I talked to these guys initially, I did some research, and there are cities all across America that are heated this way. So it's not anything new. You're right. It can be done, and it is really efficient. That's why cities have chosen to do it. It's just that I think that we've, for so many years, have been just like, well, it's just cheaper to burn oil or natural gas, but it's not. So because, again, like you've said, we're not counting all of those costs into it. So yeah, this is a great solution. I'm just so excited, like Jesse said, that you guys actually did something about it, because there's so many people out there who would have like, well, we figured out the solution. It's in this computer program, but see ya, you know.
Right.
But
or it would be something expensive. I mean, I could easily imagine a very similar system, a parallel universe where you're saying, okay, so we're going to take, this molten salt and we're going to store it in these big tanks or something like that. And it'd be like, molten salt, that sounds expensive and dangerous. And you'd be like, well, it is, but just pay me the money. You essentially took something, akin to that and simplified it and cheapified it down to the point where it sounds like something I could do in my spare time if I wanted to dig up my backyard.
don't do it.
So there are those molten salt and something like that heat storages, and in some ways the molten salts and those are better than ours. For example, they can generate more power at shorter time or something like that, but they are really expensive compared to ours. So that's once again the thing that we need different kind of storages for different kind of needs. So,
and what you talked about, you would have already a quarry in some place close enough to the consumers, and there would be this quarry and then maybe even some side rock that we could mix up with the sand. It's not that important if it's exactly sand. We just put the pipes in, fill it. You have the hole in the ground filled. And then you have a storage that you can use to heat up the whole community.
One practical problem is that we cannot deliver the heat from far away. So the storage needs to be relatively close to the end users.
Yeah. Well, if there's like a town 2-3 miles from the quarry, that's probably doable if it's like a big enough town, but like tens of miles, that's probably already too expensive to build the heat pipe there.
But I mean, in this case, for instance, like there's hundreds of homes right around the quarry.
Right.
Like, literally a stone's throw.
Right. That's why it's every 2 years that someone dies in the quarry. Yeah,
and actually, like if there's a ready quarry, that's an ideal place, since the excavation can easily be like 1/3 of the costs of building the storage. So if someone has already done it, it's really beneficial if we can use it.
I think that we have quite many ideas where our storage can be practical and useful, but I'm pretty sure that we don't know yet all the applications in which we can help. So we would be glad if anybody has ideas. We would love to hear them and then judge if they are doable or not.
So just kind of a practical question. What is the surface of your storage system looks? I mean, let's say that we filled the quarry, down the street from us, with sand. Is it just like a pipe coming out of the ground and like a little building, and the rest of it, could we grow trees on it and stuff like that?
Yeah, exactly. Just like that. Yeah.
Yeah, out of sight. Like we can put it out of sight.
Even if it's big enough storage, you could have a park over it.
Yeah, like for example, a greenhouse on top of it would be ideal, since there will be, of course, some heat loss. So if we have something on top of it that could use it, like a greenhouse on top of it, and then of course like a small hut, let's say, like even in a big system, the heat transfer. It's really like a centralized one place where there's like a small heat exchanger, which can even be hid underground if we want to.
I love that in just a few minutes, we've brainstormed a quarry, Ambry batteries, greenhouses. These are all people you can partner with. And these are just like the few that we've come up with. It sounds like you guys could work with so many industries and so many people in the world.
Yeah.
And actually, I watched one clip of yours about solar farming with like solar panels on top of the like fields. Then we can combine that also there, so we have food production, clean energy,
combined
storage, and even clean energy for the society close to the fields.
This is awesome.
This really is awesome. I mean, you guys who are watching right now, you need to share this video because there's people out there who can probably make this all happen, and we can do these things. Like this is totally doable. The technology you're talking about. Another thing I just want to point out is when I first was talking to you guys, I was like, well, 600 degrees, that would break most things in a couple days. But your system lasts a long time.
Yeah, we are planning that it will last like 50 years. The parts that are in the sand, they really have to be very well done, and they will last a long time. Only like we will have a fan that is circulating the air through the pipes. You would need to replace that in like 10 years time, but it's like 1 promille of the investment, so not a big thing.
So is that the only moving part?
Yeah, the fan and the water pump, and those are like really inexpensive.
And those are like in the little shack at the top of the, I mean, that's outside of the sand.
Right, those are replaceable.
You don't have to excavate, get to the pump and fix any. No, it's all, you're just like, oh.
That's the disaster if we have to excavate the sand. Like we really don't want to do that.
Yeah, excavation is expensive, so we want to have everything inside sand that we really trust. Well, it has to be simple, minimum amount of welds, and just like simple pipes arranged really smartly, of course. But still, like everything has to be quite off the shelf and simple systems so that they will last even forever.
And just to remind people, most of the battery systems that we're talking about today, like lithium ion, and we were big fans of the Tesla Hornsdale battery, but that battery is not really going to last that long compared to your battery. Like
it'll need constant replacement, and obviously you don't have to dig anything out of the ground, just like you don't have to dig anything out of the ground to fix your system.
But you have to worry about thermal runaway. These guys don't.
You want more thermal runaway? I mean, it's super simple. I think that's the part that I love the most about it. It's like I'm picturing myself as a little kid in a sandbox.
Right, something you could do at the beach one day.
Yeah.
Like I wish I had pipe as a kid at the beach. I would have had this. Like, darn.
Just to make sure, so we have talked about water and air. So we are circulating the air inside the sand, and then we are taking the heat to water through a heat exchanger, and the water is used, for example, in a district heating network or in a process in an industry or something like that.
Or heating the house.
Yeah, or heating the house, yes. So we are not mixing the water and sand and air, but they are separately in different parts of the system.
Yeah, because you couldn't have a liquid water pipes in sand that it's that high temperature, because those would the water would evaporate and pipes would explode.
So it's only air in the pipes. There's no water and pretty much anywhere near the system. And if you wanted to get water to go towards the pipes, it wouldn't even make it because it would evaporate long before it even reached the pipes to start to rust them. I mean, I like that part of the system too, because normally you put a pipe underground and it's like, it's going to get hot, it's going to get cold, it's going to get wet, it's going to get dry, it's going to be constantly changing, where these pipes are basically just going to be just baking.
Wait a minute. When we go to Mars, can we use your system?
Yeah, I have been thinking that. Yeah,
I'm not surprised that you have thought that.
Yeah, because of course I have been watching a lot of videos about Elon and about his plans about going Mars.
That's where we can have our hippie commune.
Yeah, hippie commune into Mars. Yeah,
that would be great. I think that's a great place to leave it. I'm so excited that you guys are working on this problem. Thank you so much for joining us today and sharing this with our audience. I'm just super pumped about your company. I can't wait to hear back from you guys in the future about what your guys are working on. So thank you so much for joining us today.
And how can people reach out to you if they want to reach out?
Yeah, thanks a lot. Of course, they can reach out to us by going our website, polarnightenergy.com. .com.